Hello students, we have studied the Pythagoras theorem. It states that in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. Today, we will study the converse of the Pythagoras theorem and its proof. Here, we have a triangle LMN where LM is equal to 6 centimeters, MN is equal to 8 centimeters and LN is equal to 10 centimeter. 10 square is equal to 100, 6 square is equal to 36, 8 square is equal to 64. 36 plus 64 is equal to 100 is equal to 10 square. Now measure angle LMN. Angle LMN is equal to 90 degree. Thus, triangle LMN is a right angled triangle. Therefore, we may state that in a triangle, if the square of one side is equal to the sum of the squares of the remaining two sides, the triangle is a right angled triangle. This is the converse of the Pythagoras theorem. Now, let's prove this. Converse of Pythagoras theorem. If the square of one side of a triangle is equal to the sum of the squares of remaining two sides, then that triangle is a right angled triangle. Let's see what's given. In triangle LMN, LN square is equal to LM square plus MN square. To prove angle LMN is equal to 90 degree, let's see the construction. Draw a triangle XYZ such that LM is equal to XY, MN is equal to YZ, angle XYZ is equal to 90 degree. Let's see the proof. In triangle XYZ, angle XYZ is equal to 90 degree. Therefore, triangle XYZ is a right angled triangle. In triangle XYZ by Pythagoras theorem, xz square is equal to xy square plus yz square. Therefore, xz square is equal to lm square plus mn square because of the construction. Therefore, xz square is equal to ln square because it's given. Therefore, xz is equal to ln. Therefore, triangle LMN is congruent to triangle XYZ because of the SSS test. Therefore, angle LMN is equal to angle XYZ is equal to 90 degree because corresponding angles of congruent triangles. Therefore, triangle LMN is a right angled triangle. Understand? Now let's consider an example. In triangle ABC, AB is equal to 9 cm, BC is equal to 12 cm and AC is equal to 15 cm. Is triangle ABC a right angled triangle? Why? Let's see the solution. In triangle ABC, AB is equal to 9 cm, BC is equal to 12 cm and AC is equal to 15 cm. Therefore, AC is the longest side. AC square is equal to 15 square is equal to 225. Equation 1. AB square plus BC square is equal to 9 square plus 12 square is equal to 81 plus 144 is equal to 225 is equal to 15 square is equal to AC square. Therefore, AB square plus BC square is equal to AC square. Therefore, by converse of Pythagoras theorem, triangle ABC is a right angled triangle. In triangle ABC, AC is the longest side. Therefore, AC is the hypotenuse. Therefore, angle ABC is equal to 90 degree angle opposite the hypotenuse. So students, so far we have studied the properties of right angle triangle with the angles 30 degree, 60 degree, 90 degree and 45 degree, 45 degree, 90 degree, as well as the theorem of geometric mean for the right angle triangle, right? We have also studied Pythagoras theorem and its converse along with their proofs. Now, we will study some examples based on these concepts. The lengths of the diagonals of a rhombus are 6 cm and 8 cm respectively. Find the perimeter of the rhombus. Let's see the solution. Observe the diagram. In the rhombus ABCD, diagonal AC is equal to 6 cm and diagonal BD is equal to 8 cm. Diagonals AC and BD intersect each other at point O. Diagonals of a rhombus are perpendicular bisectors of each other. In other words, they bisect each other at right angles. Therefore, in the diagram, length AO is equal to length CO and length BO is equal to length DO. Therefore, length AO is equal to length CO is equal to 1 upon 2 into AC is equal to 1 upon 2 into 6 is equal to 3 cm. Equation 1. And length BO is equal to length DO is equal to 1 upon 2 into BD is equal to 1 upon 2 into 8 is equal to 4 cm. Equation 2. Similarly, angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA is equal to 90 degree. Therefore, triangle AOB, triangle BOC, triangle COD and triangle DOA are all right angle triangles. Hence, in triangle AOB by Pythagoras theorem, AB square is equal to AO square plus BO square. Therefore, AB square is equal to 3 square plus 4 square, equation 1 and equation 2 is equal to 9 plus 16 is equal to 25. Therefore, AB is equal to square root 25 is equal to 5 cm. Equation 3. ABCD is a rhombus. Therefore, segment AB is equal to segment BC is equal to segment CD is equal to segment DA is equal to 5 cm because of equation 3. Therefore, perimeter of the rhombus ABCD is equal to 4 into 5 is equal to 20 cm. In triangle PQR, PR is equal to 10 cm, angle PRQ is equal to 30 degree, angle PQR is equal to 45 degree, PS is perpendicular to QR and point S lies between point Q and point R. Now find the lengths of segment PS, segment QR and segment PQ. Let's see the solution. What's given? In triangle PQR, PR is equal to 10 cm, angle PRQ is equal to 30 degree, angle PQR is equal to 45 degree, PS is perpendicular to QR and point S lies between point Q and point R. Therefore, in triangle PSR, angle PSR is equal to 90 degree because PS is perpendicular to QR and angle PRS is equal to 30 degree because point S lies between point Q and point R. Therefore, angle RPS is equal to 60 degree because sum of all the angles of a triangle is 180 degree. Therefore, triangle PSR is a triangle with 30 degree, 60 degree and 90 degree angles. Therefore, in triangle PSR, PS is equal to 1 upon 2 into PR because by 30 degree, 60 degree, 90 degree property of triangle. Therefore, PS is equal to 1 upon 2 into 10 is equal to 5 centimeter. Equation 1. Therefore, in triangle PSR, SR is equal to square root 3 upon 2 into PR because 30 degree, 60 degree, 90 degree property of triangle. Therefore, SR is equal to square root 3 upon 2 into 10 is equal to 5 square root 3 centimeter. Equation 2. PQS is equal to 45 degree because point S lies between point Q and point R. Therefore, in triangle PQS, angle QPS is equal to 45 degree because sum of all three angles of a triangle is 180 degree. Therefore, triangle PQS is a 45 degree, 90 degree triangle. Therefore, in triangle PQS, PS is equal to QS because 45 degree, 90 degree property of triangle. Therefore, in triangle PQS, PS is equal to QS is equal to 5 centimeter. Equation 1. QR is equal to QS plus SR because point S lies between point Q and point R. Therefore, from equation 1 and equation 2. Therefore, QR is equal to 5 plus 5 square root 3 centimeter. Equation 3. Therefore, in PSQ, PS is equal to QS is equal to 1 upon square root 2 into PQ because triangle PQS is a 45 degree, 90 degree triangle. Therefore, PQ is equal to square root 2, PS is equal to square root 2 into 5, PS is equal to 5 centimeter because equation 1. Therefore, PQ is equal to 5 square root 2 centimeter. What did we learn? We studied this converse of Pythagoras theorem and its proof. In a triangle, if the square of one side is equal to the sum of squares of the remaining two sides, the triangle is a right angled triangle. We also learned an application of converse of Pythagoras theorem and a combined application of theorems related to right angled triangle. Exercise. The top of a 10-meter ladder is placed against the wall. The base of the ladder is at a distance of 6 meters from the wall. Find the height of the top end of the ladder from the ground. The sides of a triangle are 9 cm, 40 cm and 41 cm. Is this triangle a right angled triangle? In triangle LMN, angle LMN is equal to 90 degree. Line MP is perpendicular to line LN. LP is equal to 20 cm and PN is equal to 5 cm. Observe the diagram carefully and find the value of X, Y and Z.